Here's the tips how to tackle application of differentiation questions. First, you need to draw a diagram and label all the important parts mentioned in the questions. Second, you need to write an equation based on the question. Third, you need to transform the equation to single variable. You need to pick the variable that will make the solving step simpler. In example, fx. Fourth, you need to differentiate the fx in order to find the maximum or minimum value required by the questions. Fifth, we will let the first derivative of fx equals to 0 to find all the x values. Sixth, you need to do a second derivative test in order to test whether the quantity is maximum and minimum. Don't forget to write the conclusion as well. And lastly, you need to calculate the maximum or minimum values by substituting the x values into the equation.
Example 1. Draw a cylinder and label H and R. I already draw the cylinder beforehand. 1 Roman, show that the volume of the container is V equal to 150 pi R minus pi R cube over 2 centimeter cube. In this question, is it given that the total surface area of the container is 305 centimeters square? So, we can write the formula for surface with one open and one closed end. Pi R square plus 2 pi R H equal to 300 pi. Here, we can cancel out the pi, meaning that our equation now is R square plus 2RH equal to 300. Let H as a subject. Then we get H equal to 300 over 2R minus R square over 2R. Here, we will simplify whatever that we can simplify. So, we get H equal to 150 over R minus R over 2. Next, since the question asks for volume, we will use the volume formula. V equal to pi R square H. As you can see, here we can sub the H. Then we get V equal to pi R square in bracket 150 over R minus R over 2 close bracket. We'll expand it and we get 150 pi R minus pi R cube over 2 shown. Next, the question asks for the maximum value for the volume. First, we will use the V that we have shown earlier and differentiate it. V equal to 150 pi R minus pi over 2 R cube. dV over dr equal to 150 pi minus pi over 2 multiple 3 R square. Let dV over dr equal to 0 to find all the R value. So we get 150 pi minus 3 pi over 2 R square equal to 0. Let R as a subject, so 150 pi equal to 3 pi R square over 2. Then we cancel up the pi and we get 150 equal to 3 over 2 R square. 300 equal to 3 R square equal to 100, R equal to plus minus 100, R equal to 10. Since R more than 0, so R equal to positive 10. Next, we will do the secondary test. dV over dr equal to 150 pi minus 3 pi over 2 R square. d square V over dr square equal to negative 3 over 2 pi multiple 2R. Then we get negative 3 pi R. When R equal to 10, d square v over dr square equal to negative 3 pi multiple 10. Then we get negative 330 pi less than 0. This is the maximum value. The conclusion is very important. So, the volume of the cylinder is maximum when R equal to 10. Now, we can calculate the maximum value of V by substituting the R with 10. So, V equal to 150 pi multiple 10 minus pi over 2 multiple 10 power of 3. And we get 1500 pi minus 500 pi. Lastly, we get 1000 pi centimeter cube.